Good morning and welcome to this NLA event with VU.CITY on generative design and using collaborative tools in the built environment. I am Ellie Davis and I'm a programme manager at NLA, and I'm delighted to see so many of you joining us this morning. So we are NLA, London's built environment community. For access to hundreds of events, research reports, exhibitions and business critical industry insights, you can become a member of NLA at nla.london now to be part of the conversation. So this event is a webinar by VU.CITY hosted by NLA as part of our CPD programme. Today we will hear from Tazeen Raza, Architecture Sector Lead at VU.CITY, and Paul Jeffries, Director, Head of Automation and Computational Design Buildings at Ramboll, who will discuss SiteSolve's origins and talk us through some examples demonstrating how SiteSolve can be used in London. Following the presentation, we will have a panel discussion followed by audience Q&A, where there will be opportunities to ask Tazeen and Paul questions. So please do send these in via the Q&A button on Zoom throughout. Now I'd like to invite Tazeen and Paul to begin your presentation. So over to you both.
Thank you so much for the introduction, Ellie. I guess we could start off by just going through the title of this webinar, Generative Design, Collaborative Tools in the Built Environment. So let's start off by unpacking what the term generative design actually means. We've been hearing it a lot in the built environment over the past couple of weeks, months, years, but is it just another buzzword that's come about, or does it actually have a lot more longevity attached to it? So between Paul and myself, we've come up with a working definition of what generative design is, and I'll try and begin to unpack that. So effectively, it is a process in which the designer inputs a series of parameters which are used to generate iterative design ideas that can be optimized as part of a feedback loop. Now, that's quite a dense definition, so let's just unpack that a little bit. The first word I'd like to draw your attention to is designer, the person or the team of people who are actually performing this action or this process. The second one is the iterative design process, where that after one has set initial design parameters or success criteria, which may be the target GEA or the apartment mix or the apartment types or the net to gross ratio, they can be optimized with every single design option that the tool generates, which can be 10 options, which can be hundreds of options, and with each option it gets closer and closer to the desired outcome. Now, the last word I mentioned was feedback loop. A generative design tool, whether that be SiteSolve or any other, has a constant feedback loop, which means you can constantly start editing those outcomes to make sure that they are what the designer has desired. Now, the question arises, why do we need to do all of this? You know, we have been constructing buildings since prehistoric times. What's the change? What's the urgency? What's the point? So Paul, maybe you'd like to share a little bit more about the origins of SiteSolve?
Yes, thanks, Tazeen. Happy to. If we can move on to the next slide. So SiteSolve started its life as an internal development with us in Ramboll. So Ramboll, as many of you will be familiar with, is a large international engineering consultancy. And in fact, my background is in structural engineering. So a lot of the kind of very early applications of this set of techniques that we were looking at were things like rationalizing structural geometry in things like stadium roofs, which need to very often be kind of broken down into repeatable components in order to be built, and where the efficiency of the structure is very important. So we started using computational design optimization techniques there, which effectively kind of generate and then improve on different design ideas in order to do that. And there's kind of an example on the screen there. And we kind of continued to apply these different techniques. So we've also done a few different things, looking at a variety of different things. So there's the other example on the screen here is where we were looking at an oversight development, effectively building a deck over a railway line, and then looking at different options for doing that, the load capacity that applied to those different solutions, and therefore how tall you could potentially build on top of that. So that diagram there is showing a range of different generated options, and the maximum potential envelope for development above the deck is what's shown on the right hand side there. Coming a bit more into the realm of architecture, if we move to the next slide, something else that we were frequently kind of asked to do, and we got a lot of interest from clients in doing this, was in taking master plan arrangements and initial architectural designs, and running them through optimization algorithms in order to improve various aspects of them. So in the examples that are shown on the screen here, this is really all about maximizing the quality of views from apartments within buildings, and looking at essentially taking an arrangement and then making small tweaks, either of height or orientation of buildings, in order to achieve better outcomes, better views, therefore more potentially valuable apartment spaces, and more pleasant spaces to be in, effectively. So we have used generative design, computational design more broadly, for a huge number of different things, and we found a huge amount of different value in doing that. But if we move to the next slide, one of the kind of key benefits that we found that crossed over a lot of these different applications was that essentially it allowed us to get more knowledge about a design earlier on. So those of you who've worked on design projects will probably have experienced something similar to this. At the very start of a project, that's where you have very often the most freedom to modify that design. It's where the big decisions get made, but you also have the least knowledge about the implications of those decisions very often. As you go through the design process, you gain more knowledge about the design problem, but those big decisions get locked in, and you very often end up not being able to make the big changes that you might like to make. So very often the end of a design project, a kind of common refrain is, oh, if only I'd known this at the start, we might have done something a bit differently. And what we found with these different computational optimization and analysis and generation techniques was that they allowed us to push that knowledge earlier on in the design process. So we could, through kind of looking at things in quite a high level of detail, but very early on at the concept stages, we got that level of knowledge, that level of input that allowed us to make better decisions. And what our kind of hypothesis there was, okay, as engineers, we enter this process at a certain stage. What if we could use this, we could build technology that would allow us to provide this boost in knowledge at a stage before we as engineers on a project would even typically be involved? What if we could kind of automate some of the early stage advice that we would give if it was economical to involve us at that stage? And that's really where the core idea of SiteSolve came about. It was about embedding our engineering intelligence into a tool that then architects and developers could use at early stages to help to shape their critical decisions. So if we move on to the next slide, essentially what we looked at doing was in taking all of these different generative techniques and analysis techniques and optimization methods that we'd used on a variety of different things in the past, and start to bring them all together, so that we could fully automate the design cycle. So we could generate new ideas, we could then evaluate those ideas, and through an automatic process, based on the results of that analysis, make tweaks to that initial geometry, and thereby loop it around in order to optimize that geometry and effectively generate new options that were continuously improving. And I guess the other thing that we also realized as users of this technology ourselves is that it's not enough to just make this a closed loop. You also need to provide user input into it. You need to be able to override certain things. The computer can't do everything. There might be times where you want to be generating the options yourself, or you might want to be inputting into the evaluation of those, or you might want to be the person that's saying, okay, based on this analysis result, we will make that tweak. So a huge part of building this tool actually and actually making it a really useful tool has been in giving you the freedom to allow the computer to take control of these different elements of the design cycle, but also allowing you the freedom to manually intervene and effectively kind of create the design collaboratively alongside the software. So that's where we started to build out the tool that became SiteSolve. And within Ramboll, we use that tool in a number of different ways in our consultancy work. So on the next slide, one of the things that we started being able to offer our clients through having this technology and making it kind of fast and efficient to use, as we could offer workshops where we would sit down with developer clients and their architects, often in one room. We could very rapidly run through a bunch of different design scenarios. We could look at optimizing different things. And through doing that, we could provide very rapid feedback that would help to look at the feasibility of sites and on the strategy that might be taken to approach that from an architectural and development perspective. So we offered this to clients looking at kind of individual sites, but also if we move to the next slide, we offered it on a much larger scale as well. So there's a project that we did for TfL in London, where we were essentially looking at over 2,200 sites initially. And obviously that would take a very long time to do one by one. But what we were able to do using SiteSolve was to feed all of that all of the different information about all of those sites into SiteSolve, essentially kind of batch process it, look at thousands of sites in one go, and be able to see, okay, what's the actual development potential of these sites? And because a lot of them would sort of owned by TfL initially, they were very often kind of long, thin sites that were next to railway lines, things like that. Stuff where if you just did a very basic analysis on that didn't consider access and things like that, you wouldn't get the right answer out. But what we were able to do was effectively provide a database of all these different potential development sites with a realistic appraisal of what you could fit on there, what their real value was in terms of housing development. So that was how we started using it internally in Ramboll, but we always saw that there was potential for the tool itself to be something that other people could use, and for us to essentially kind of commercialize the tool itself and bring it out to other people. And that, among other things, is why we started to partner up with VU.CITY to help to commercialize this tool. So Ramboll, we're an engineering consultancy. We don't really sell software as a business. It's very different to our kind of core model. But by partnering up with VU.CITY, we were able to then commercialize this tool in a way that we wouldn't have been able to do on our own. So on that point, I'll pass over to Zine.
Yeah, thank you so much for that, Paul. And I guess on that note of commercialization, we can sit here and talk about all the brilliant things that SiteSolve and VU.CITY can offer, and they do. And actually, prior to this webinar, Paul and I have not been able to hold ourselves to just have a 1 hour long conversation on generative design. It can extend for much, much longer. But I guess I want to shed light on one of our kind of key and very valuable customers amongst all, which is the Clarion Housing Group, who have widely embraced this change and this new technology, and alongside their development branch called Latimer as well. So they are actively using SiteSolve to generate lots of different ideas, which you can actually listen to in a podcast yourself, which was hosted by Place Northwest. So Dave Lee, who's the director from Clarion Housing Group and the commercial director at VU.CITY, kind of sat down in a room and were quizzed about what SiteSolve has to offer, and where we see it going in the future, and challenges that it presents as well, and any limitations as well. So it was kind of a really nice holistic conversations, very balanced. And one anecdote, if I may share, is that Dave Lee mentioned that he had a site up in Birmingham and he had to generate almost 36 entirely different options to assess and to evaluate before taking it further. And that process took about 9 months from start to finish. This is still at the conceptual stage. And then we invited him to assess the tool and see if he was able to get to the same outcome using SiteSolve, and if he was able to save any time. And the conclusion was that a lot of those options could have been, in some way, shape, or form, been achieved using SiteSolve in less than a day. So if we compare that time frame from 9 months to less than a day, that's quite significant. But let me caveat this: that's not an entire feasibility study or an entire planning application that we're suggesting you can complete in half a day. It's the initial kind of needs and demands analysis, that quantifiable measures that Paul has just very comprehensively mentioned. So with that information, I want to actually take you through what a round trip between SiteSolve and VU.CITY looks like. I'm going to try and do it justice, because I am presenting this in front of the person who's actually helped create the software. So Paul, please do jump in if I say anything incorrect. So initially, let's start off in VU.CITY. So VU.CITY and SiteSolve work really well as a team, but SiteSolve also works completely independently as well, and is not limited by geography. So effectively, you can use it internationally or locally in London and any other city in the UK as well. For this instance, I've just selected a site up in Southwark, not too far from VU.CITY's offices, on Camberwell Road, and I've used the data layers that VU.CITY has to identify if there are any site constraints in the area of my choice. As it so happens, there is a site constraint. There's a protected view number 53, which is a direct viewing corridor from Camberwell Road to St. Paul's Cathedral. Now that means there is a height limitation in this area, and there is a specific, we wouldn't be allowed to exceed a certain height when proposing a built environment scheme. It just will not get approved. That is indicated by the red and yellow bands, the triangular corridor that you're seeing. Anything that's red is an absolute no-go zone. Anything that's yellow, we might be able to have some sort of a conversation, but it then needs to kind of really adhere to those policies and justify what it's providing to society effectively to be able to exceed that height limit. So now that we've understood what that major site constraint is, we can start understanding a little bit more about the surrounding context before going into SiteSolve. So we looked at the area in question at a plan view from a bird's eye view. Now we can look at it from a more perspective view. We can get up closer. So you can see this building in the center, which is a cyan blue. That's the building in question. It's actually a supermarket at this point in time with a Lebanese takeaway in the corner. But for this instance, we're just going to hypothetically play around with it. In the background, however, you can see the timeline tool, which shows everything that's in blue is a building that is under construction in present day today. And everything that's in yellow, every building is consented. It's been given that Section 106 approval, and it is due to start construction in the near future. So looking at that site in more detail now. So now we looked at an urban scale, aerial scale, then urban scale, and now actually building scale as well. So let's see if we can actually hide it. So within VU.CITY, using the updated hide tool, I've actually just gone ahead and temporarily removed the existing building and trees so I can create my own massing. Now here I've used the create tool in VU.CITY to create a building envelope. Now, of course, this is not a potential proposal for a building because, gosh, that's monstrous. Who would want to approve that or live in it or anything of the like? So effectively, this massing outlines the capacity that's available on the site in terms of height, in terms of width, in terms of area. Now, what we'll do is export this from VU.CITY and take it into SiteSolve. But before that, we're just going to double check that our viewing corridors line up. And we can see that there is a little potential constraint on the south side of the site. So we just need to be mindful of that. Now, so we've exported this massing from VU.CITY and we're now bringing it into SiteSolve. So SiteSolve is an independent desktop application, whereas VU.CITY is both desktop and cloud-based. So I've opened up this new software and you can see, or we can all see quite distinctively that it has read some information from VU.CITY. Now that information is the site boundary and the height mesh. Now at this point, we have the option to import some context, and we also have the option to import a more kind of site plan that's a PDF that outlines exactly what the access points are, where the roads are, where the arterial roads may be, main roads, or anything of the like. So it is open to the user to identify and customize their user experience. For this instance, we're actually just going to work in isolation, just so we can focus on the building in and of itself. Now, SiteSolve reads a bit like a book from left to right. So initially we've looked at the file. Now we're going to look at the site. So I've just zoomed in on the toolbar here, and I want to draw your attention to 4 different key features. There's many key features and I could talk about them all day. So I've just selected a few. The first one is access points. We want to actually identify and really understand our site and allow the algorithm to understand the site. The output from SiteSolve is as great as the input. So we want to put in as much information at the earlier stages so we can get a really nice and refined output. So maybe there is a pedestrian access point at some point of this site. We saw that this is based on Camberwell Road, which is the main road. So we want to be mindful of pedestrian access. Maybe we want to take into consideration where the service access is and other transportation access routes as well. Secondly, you can see exclusion zones. Maybe there are some areas that we don't want the algorithm to generate any building on. Maybe that's a landscaped area, maybe that's a historical landmark, or maybe a potential car parking spot, anything of the like. Often we find that for master plans, there might be different site edge setbacks for every single plot that you may have. So maybe within a plot, you are not allowed to build, let's say 10 meters from the edge, and for others, it might be 4 meters. So you can start drawing in and really kind of customizing that to your site. The third one is a height mesh. So we notice that we have a little bit of a site constraint on one of the corners of the building, which has to be slightly lower than the rest, or the entire building has to be lower for it to be granted planning permission. So you can start customizing that as well. Maybe certain parts of the building are lower and certain parts are higher. So you can definitely adapt that. And then the final one is you can scale that site plan if you want to have a little bit more understanding of what's going on around the site. Now we can get into actually creating, which is the third tab. So we've done file, we've done site, and now we can create. Now this is where the magic happens, but actually it's not magic, it's a very prescriptive rule set. So at this point, we can start having a look at all the different parameters that we have, and it is up to the user to define what that success criteria looks like. So here you can see over 10 different titles or headlines, and each of these tabs can be expanded to, let's say, 10 additional fields. So quick maths, we can see over 100 different parameters. I'm not going to go through every single one. So I'll just select a couple that we can walk through and talk through together. And again, just going to emphasize that the more detailed the input is, the more refined the output will be. So let's start off with our general targets. which can include the likes of the total GEA, what the mix of that master plan or that site looks like. Maybe your site requires 50% offices, 40% apartments, or 10% housing. Or alternatively, in this example, I'm actually going to move forward with 100% apartments and 0% offices and 0% housing. On the right-hand side, you can start unpacking what those residential blocks look like. So exactly what is that configuration? Are they O blocks? Are they courtyards? Are they L-shaped or are they not? So you have the option of selecting and deselecting. You can also look at the different apartment depths, minimum stories, maximum height. So there's a lot of ranges which allow a lot more room for flexibility. Also, we can look into corridor widths. So right now, the default setting is 1.2, but maybe you want to make it larger to make it more accessible for wheelchairs. So you can definitely override that setting and personalize it to your use case. Next, let's look at the different apartments. But just because the site that I've chosen is quite a residential area, so we don't really want to introduce offices in that area. So let's keep it quite residential. And here I'm looking at the apartment mix. So maybe in my site, I want to have 15% studio apartments and one bed apartments, 2-bed apartments, 3-bed apartments. But I think I've not really included DDA apartments here. So I could always add that in as an additional apartment mix type. And maybe that's 1% of my entire apartment mix. Then on the right-hand side, we can go exactly into each and every single apartment type and nominate what those numbers are going to be for the minimum area, the minimum width, depth, occupancy, and how many habitable rooms are expected. We can even stretch it as far as attaching a value to it in Great British pounds and do a little cost analysis at the end. So it really and truly is up to the user to really personalize this tool. You can, of course, clone this or add more apartments or delete more apartments as you see fit. Then we can look into my possible favorite part, which are the residential cores. I say this because I have an architecture background and a little bit in generative design, and I know that cores are just they are the central part of a design design scheme. So of course, building regulations and fire safety is the most important aspect when designing any building. We are responsible for people's lives effectively, so we need to make sure that it's safe for people to enter and escape in the unlikely event of anything dangerous. So how are these residential cores allocated within SiteSolve? So you've got the option to kind of customize the core to end distance options, core to end spacing, core to core spacing, and even identify how many apartments you'd like to have per core. Maybe that's 3, maybe that's 8. So again, SiteSolve is giving you a range to work with, and you can fine tune that if you know exactly what you're after, or be open to a range of different ideas. So as with any software, whether that's SiteSolve or any other generative design tool, one of the most important things is staying up to date with policy and how building regulations are changing to improve our safety over time. So quite recently, over the past couple of months, there's been a new legislation for the second means of escape staircase when a building hits a certain height. Once that was legislated, a lot of architects had to revisit a lot of their plans. And that's where Ramboll was astronomical and instrumental in updating the code very, very quickly to introduce that functionality as well. So SiteSolve does take that into consideration for taller buildings. Now, once we've set all of the targets, I did mention there's about over 100, and we've looked at, I think, about 3. So once we've implemented all that creation part and setting the success criteria, we can identify what our overall targets are for the generation. Do we want to maximize efficiency? Do we want to maximize net area, or a primary view, or deal aspect, or maybe a combination of all of the above? Once we've done that, we can press the big triangle button, which is on the left-hand side of this screen, and that will start the generation. Now, once it's had a little bit of time to generate, it will come up with a few different options, which we can store as and when we wish. But let's say I'm not quite happy with that. And that's not a software issue, that's actually a user error because I didn't put a lot of information in. So let's go ahead and add a transportation route, which is a line that you can see cutting the building or cutting the site even from the top to the bottom. And let's see if that will respect the next generation. So I've actually added another site constraint, and I can see that, okay, it's not generating a certain distance on either side of that transportation route that I've created. So I'm quite happy to know that that route and that site constraint has been respected by the algorithm. Now, once I'm happy with my generation, I can start analyzing it and understanding whether or not it works for me. So once I've generated multiple ideas, I might want to look at certain viewpoints that I've identified as the primary view. So here I said I would like to have south-facing apartments to be green, which are effectively a good view, and anything that's red is a less good view. So if I'm happy with that, I can carry on. If I'm not, I might regenerate so I have a greater number of green-colored apartments. In addition to that, we can also look at sunlit hours if that is important to the scheme, if that's important to the design at that stage. And then we mentioned right at the very beginning that a generative design tool process is cyclical. There is a feedback loop. So once you've got that idea, maybe you like it, maybe you don't, you've optimized it, then you can go back to the beginning and start adding a bit more information to make it more refined. So here, while I'm looking at the inputs and looking at what it's generating, I'm also keeping a very close eye on the outputs numerically as well. So here I've looked at units with primary views. Then what we can do is, once we're happy, is we can bring the desired generation back into VU.CITY to understand a more holistic and the building scheme in a wider urban context. So here's just a couple of shots showing that. And this is effectively a whistle-stop tour of a round trip between SiteSolve and VU.CITY. Paul, tell me if I've missed out on anything.
No, that was very good. I mean, there are certainly elements of the software which I don't think we have time to go into any detail on, but yes, I think that was a very good summary.
Oh, I think you're being too kind. So I think with that, we've come to an end of the actual presentation. Ellie, I'll throw it back to you.
Perfect. Thank you so much, both. It was great to have such a detailed presentation, and also really interesting to hear how Clarion are currently implementing the SiteSolve program. I would like to remind the audience that there will be an opportunity to ask our panel some questions in our Q&A session, so please do keep these coming in via the Q&A button on Zoom. So I have a few questions in the first instance for both of you. So my first question is, should built environment professionals be concerned about technology such as generative design?
I think it's certainly a common question. And when we were kind of initially showing off SiteSolve to a few of our kind of developer clients, and they'd often bring their architects in, and the first thing some of the architects said to us was, "Oh, you're here to replace us, are you?" And no, that's that was absolutely never our intent. First of all, I'm an engineer, not an architect, although we do have architects on the team, so I wouldn't know where to start with replacing architects. But I think it's important to say that SiteSolve doesn't really do architecture in the real sense. It's more looking at feasibility and examining potentials and things like that. It's very much designed to be used by an architect, or to be refined by the architect, to actually sort of deliver on the real sort of architecture aspects of it. I think the software by itself can't do what an architect does, but the idea of the software is that an architect using the software can do better than an architect who isn't, essentially. So that's the sort of philosophy we've taken with SiteSolve, and I think that applies across a lot of the different generative design software out there. A lot of them are not really, intending to replace architects at all. I think, but of course, with recent changes in AI and things like that starting to move more into creative professions, it's certainly a valid question and a valid thing for people to worry about, I think.
Yeah, fantastic. Tazeen, do you have any comments on that first question?
Yeah, I think it's a really valid concern. And I think it's important to address the elephant in the room whenever you're talking about generative design. So I definitely am in complete agreement with Paul. This is a part of the process, and it's at a very early stage. It's not designed to get you through the entire design process. And as we mentioned right at the very beginning, generative design is a process that's driven by the designer. It needs that human element. An algorithm cannot implement spatial qualities or that human empathy that we desperately need in any design. I mean, I'm in a really nice office right now. I mean, a lot of this is designed by the human element, and it wouldn't be this spacious or this cozy or this inviting if it wasn't. So I think we probably need to keep in mind that this is only designed to get you to a certain part of the process and not the entire way. Now, conversely, let's look at the positives. Historically, we've always strived for improvement within the built environment. Back in the day, architects were using A0 sheets of paper and pens and scaling rulers and set squares and pens again. And if anyone made a single mistake, they'd have to redraw it from scratch. And then came the arrival of the CAD drawing software, where you can start drawing, albeit manually, but you can start drawing digitally, and you're able to just speed up that process a little bit more. So the architecture industry has constantly been evolving and has been at the cusp of transition into the digital age for a while, and it's finally happening. So if anything, I'm quite excited for the future, because it means our workforce will be upskilled. We work with algorithms on a daily basis. If you are anybody who's an Instagram user, that content that you see is not new. It's been collecting your data, and it's crafting that information for you. If you're somebody who listens to music on Spotify, it's the same scenario there as well. It's just a different way of consuming that information. Historically, yes, we've been in the consumption age, but now we're just in the experience age. And what's the harm in kind of bringing that into our professional life as well? So I'm quite excited about the future and where architecture is going to go. If somebody has 3 weeks to complete a feasibility study, there are 2 ways a designer can approach this. Maybe they'll say, hang on a sec, we want to complete this in 2 weeks, so we have an extra week where we can start off on the next task. That's fantastic. You have more time to actually design. Conversely, you might say, if I have 3 weeks, I'm just going to make sure that my design proposals are going to be very, very data-driven and informed, which is another positive way of looking at it. So there is definitely like a glass half empty or a glass half full approach to this. And I think we're definitely on the more positive side of the spectrum in this webinar.
Fantastic. Thank you so much, both. It's very nice that you're honest about both the pros and possible cons of these programs. Perfect. So my next question is, where else have you seen generative design work well?
I think there's quite a broad range of applications for it. So I've touched on in my intro bit on how we use it in structural engineering to optimize structures, make sure that we're kind of reducing the overall mass of that and so on, especially for kind of long form roofs like stadiums and things like that. It's also used a lot in the kind of automation and mechanical engineering side of things to sort of structure optimize components and make sure that things are very lightweight. I think we're also starting to see a lot more tools that kind of branch into other industries as well. So when we actually first kind of founded SiteSolve, our initial kind of placeholder logo and branding for that came from an online generator that kind of just spat out a bunch of different logo options and things like that, and we picked one to be going on with until we actually brought in a professional to design it properly. So there's a range of different kind of uses of that. I think it's probably also important to say that there's a longer history of this in architecture than people may in fact realize. If we look at Anthony Gaudi, for example, so he died before computers were invented, but if you go to the Sagrada Familia in Barcelona and go down to the basement there's a museum there, and you can see down there these beautiful kind of hanging chain models that he created to help design some of his buildings. And the reason that he did that is because a hanging chain, it naturally kind of adopts the form that resists forces purely in tension. If you flip that upside down, you get a form that's very strong and very good at resisting forces in compression. So if you build something out of stone, you're going to get a very kind of efficient form doing that. So effectively what he was doing there was he was creating a kind of very early form of parametric model where he was controlling the distribution of the chains and the sort of support points of that, but the actual form of the building in large part was being generated by this process, and he was then using that to help guide his designs. And I think what we're talking about here is a bit of an evolution of that same kind of approach to design. I think we have a bit of an advantage over Gaudi now in that we're not just restricted to what processes we can physically model. We can kind of model any process we want now. But I do see it as kind of a successor to that kind of approach.
Fantastic, thank you. Tazeen, do you have any comments on Paul's answer?
I mean, I'm led by Paul on this because he's had much more experience in the industry than I have. But no, I always love the Gaudi example. It just kind of goes to show that we've constantly been evolving, and we always will. And it's whether or not we're brave enough to embrace that change or not.
Fantastic, thank you. And my final question, how can generative design help keep up with London's housing demands?
Yeah, I think obviously this is quite an important question, and it touches on a lot of people's lives. I think ultimately the real issue we have is that land is the one thing that they're not making any more of. We have a fixed quantity of land available to us, barring filling in oceans and things like that. And the onus is on us to make the most efficient use of that land that we possibly can, and to bring land into use in a way that economically makes sense. And I think SiteSolve can help with that. It can help with identifying and optimizing the way that you position mass on a site to get the most number of apartments out of it, for example, and also to speed up the process of looking at land so that developers know where they're going to get the best return and therefore what's going to be most financially attractive to them, and help them kind of unlock sites that potentially might not go into development otherwise.
Yeah, I'd just like to add to that. I mean, the housing crisis is definitely something that we should all be really mindful and kind of concerned about. But at the same time, we also need to be considerate of the quality of the housing that is going to be built. We can't just build for the sake of building. It needs to be, the buildings that we design need to be alive for a very, very long time and be serving the changing needs of the people and the changing demands of the climate as well. So if these kind of softwares like SiteSolve and generative design tools at large can help kind of interpret data in real time to ensure the things like building heating, building cooling systems respond to weather conditions and damages and so on and so forth, then then that's a job well done. Ultimately, I'd say that the role of SiteSolve and generative design tools in at large is to help the designers and developers develop more informed decisions, and also be able to customize that for the different needs of different locations. So maybe you want to design vertically in certain areas, but low-lying buildings in other places. So the ability to customize that and then optimize that for different locations is definitely the right direction to be able to serve that demand.
Fantastic, thank you both. I would now like to open up to questions from the audience. We've had quite a few coming in, but please do keep these coming in via the Q&A function on Zoom. So the first one I will ask is, how do you see the abilities of generative design developing over the next couple of years?
That's a very good question. I mean, I think I think a lot of the actual techniques on offer here, they've actually been around for a long time. I think the key kind of movement now is in making them more accessible to people and making them easier to integrate into people's design processes. I think we're also seeing now a lot of newish again the kind of the basic principles behind a lot of the kind of AI stuff that we see with neural nets and things like that. They've been around for a long time, but there's been some kind of breakthroughs recently, obviously, in how those apply and things like that. So it'll be interesting to see how those manifest in the architecture and engineering space, I think. I think there's a challenge there in kind of taking those things from how they've been applied at the moment to things like images and text, and then kind of applying them to the problems that we're trying to solve in AEC. But yeah, it'll definitely be interesting to see how that gets taken up and how we can make use of that.
Fantastic, thank you. And Tazeen, do you have any comments on how you see generative design evolving over the next 5 to 10 years?
Yeah, if I may kind of go back to my architectural roots and put the architect hat on, I would actually love to see kind of more building regulations incorporated into generative design tools. So we mentioned that softwares are in a way led by policy, and there are different policies for national requirements, regional requirements, and even district-wide requirements. So if we were to able to incorporate all those different policies within the very prescriptive rule set that SiteSolve already has, so instead of 100 parameters, it might be 200 parameters, but effectively the generation that you'll get is pre-planning approved. So once you go to the planning committee, you can say, actually, this has hit X, Y, and Z different variables that you're looking for. So let's speed up that process and get to the next stage of actually start designing these things. So from a very practical and safety perspective, I would like to see, well, I would hope to see more building regulations being incorporated.
Yeah, fantastic. I think that's a great idea. I think we should try and see if we can implement that maybe in the future. Perfect. So another question from an attendee: do you see generative design as a potential constraint to creativity, where all buildings will just look like different versions of each other?
So I think no, I don't think it is a constraint. I mean, I think there is an element of course, where tools start to influence the design process. And I think there's a number of buildings that you can sometimes point out to and say, oh, that was designed in Rhino, or that was designed. I think you can kind of start to see the DNA of some of the tools that are made kind of going into that. But I think within that, there's a huge amount of range of creativity still kind of able to be built on top of that. And I think even in fairly kind of let's say straightforward cases of doing design optimization and things like that, the key outputs of those optimization processes very often, as I said at the start, kind of knowledge about a design and about the design options and the design principles. And I think the key kind of challenge here is some elements of what make a design good you can quantify, but a lot of them you can't. There's always going to be a question of matter of opinion and design philosophy and approach and things like that, and all these kind of different things that go into what makes great architecture. So I don't think that it will constrain too much. And ultimately the aim of all this software, at least as far as we're concerned, is it should be taking care of the stuff that is fairly rote and routine, and allowing the designers more time to actually focus on the elements of the design that do add value and are different, and do differentiate themselves from others.
Yeah, this is definitely one of my favorite questions. Just because we get it a lot. Yeah, no, absolutely not. It's not the design tools, generative design tools in general, we have to remember are implemented in the very, very early stages. So if there are 8 stages in the REBA process. Generative design tools will come at the very, very beginning. And then it is up to the architect. And I would like to emphasize how important the role of the architect here is to introduce that design element. SiteSolve will help you understand the capacity of what you can get on a site. It's not designing form, it's not designing facades, it's not designing any of the lot. It will take into consideration the facade zone depth, for example, but it's not actually doing the designs that you see once you're walking out in London and you think, wow, this is a really nice building. I wonder would generative design tool design that? Of course not. So I think we should definitely be mindful of understanding how far the tool is designed to get you there. And then the rest is kind of the onus is up to the designer to be able to bring in that design philosophy, as Paul mentioned.
Fantastic, thank you both. Another question from an attendee. I'm interested, please, in how local planning authorities can use or are using this tool to deliver greater efficiencies and improve collaboration. So if anyone can please share insights on this topic.
I think there's a number of different ways. I mean, I think a lot of planning authorities have looked at this as kind of, a way of testing out sites that they want to push forwards into development. But I think it's also useful for them just to assess the potential of sites and to, understand what could be fit on that site if in a sort of fully optimized location. And I think that helps them to set the brief, make sure that what they're asking for is reasonable for sort of for the sites that they're passing on to developers and architects to look at in more detail. And I think it also helps them to guide policy. So a part of the work that we were doing with TfL was to help them with, looking at the land available and then make policy decisions based on that. And sort of strategic directions for how they wanted to carry forwards. So yeah, I definitely see use cases there, and some authorities have started using that.
It kind of comes back to that feedback loop, doesn't it? So at one instance, you're the user, you're testing designs, you're then optimizing it, and then ultimately that helps drive that policy. And we're in that cycle of a positive and more productive space to live in.
Fantastic, thank you both. And now probably the final Q&A question we'll have time for. Should we be prioritizing the use of generative AI to benefit LICs more than HICs? Are there more ethical concerns that we face by using AI in developing countries, cities, or places? I'm assuming you both know what those acronyms are. I don't, unfortunately.
I don't, I'm afraid.
So I'm gonna just hazard a guess and assume that they're referring to low-income countries and high-income countries.
Mm-hmm.
If they are, then it just varies. Again, I mean, it's to understand the amount of capacity that is available in a lot of kind of developing and in low-income countries. The metropolitan cities are growing more and more vertical, and like Paul said, I'm going to echo that. We don't have more land, so we just need to be very considerate and smart about how we're using the existing land. So it doesn't matter whether you're a high-income country or a low-income country. The ultimate goal of SiteSolve and generative design tools at large is to help identify how to best use the limited resources of land we have.
Fantastic, thank you. I'm going to squeeze in one more question from the audience. What apartment layouts are the apartment mix / volumes based on?
So they can be set basically. So the apartments themselves are purely volumes, and you can control the parameters that determine kind of what size they are and how many beds they are and what the occupancy rate is and all that kind of stuff. So they're the kind of default values, I think, are based on some of the London plan kind of minimum values and things like that. But there's a lot of freedom within the tool to adjust that to suit your own apartment layouts and kit parts and so on.
Perfect, thank you. Great, so I'd now like to bring our discussion to a close. So thank you again to our speakers, Tazeen and Paul, And also thank you to everyone who's joined us on this lovely sunny Friday morning in London. Please do have a look on our NLA website for our upcoming events. We've got a few coming up next week. We have a Petra Kucha on decarbonising school estates on Thursday, the 23rd of November. And as part of our City Dialogues programmes, we also have a webinar titled Towards Circular Cities, London and Copenhagen on the morning of Friday, the 24th of November. So please do check out our website for details. We will now also have a short poll for the audience to give us some feedback on the session, as this is really useful when we're planning our future events. We really hope you enjoyed this webinar and hope to see you again very soon. So yeah, thank you everyone, and hope you have a lovely day. Thank you.